Hello, everybody. Thank you so much for coming to my talk. I'm excited to talk to you about securing your software supply chain using Argo CD, Open Policy Agent, Open GitOps, Kyverno, and a project called SIG Cosign. And this is, I titled this talk Secure by Default with GitOps because this is a way of creating a kind of policy-driven approach to security where you don't necessarily have to check everything as part of your kind of build process because you have mechanisms in place that are going to make sure that things are enforced at every level. And one of the deficiencies I think of CI/CD in the past has been that you have maybe policy engine as part of a pipeline, but then not a way of actually enforcing that beyond that. So if somebody were to bypass the CI/CD pipeline, they get around it. So this is going to be a default security, creating a default security using these really cool tools. All of these are open source tools you can use. So to kick this off, let me introduce myself. My name is Dan Garfield. I am the co-founder and chief open source officer of CodeFresh. We are a software delivery company. We are the Argo enterprise company. We have a lot of expertise implementing GitOps, implementing Argo, implementing CI/CD, implementing software delivery. We've been around for about 5 or 6 years and been very proud of this team and what we've built. So definitely check out our platform because we have some really great tooling for you to use to deploy software and deliver it securely and at scale, making your developers productive, all those kinds of things. You can follow me on Twitter at @TodayWasAwesome. And then I am a maintainer on the Argo project. Now, truthfully, I don't write that much code. Every once in a while, I do a little bit of code contribution. Most of the work that I'm doing is helping organize and organize contributions from our developers, helping organize in the community, helping build our community events and all those kinds of things. So while I do contribute every once in a while in the code base, most of the work that I'm doing is in the community side of things and on helping organize work and build governance and all this kind of stuff. I'm also a maintainer, co-founder, and co-chair on Open GitOps and the GitOps working group. So this is a group that we created under the CNCF to create standards and principles around GitOps. You can check it out at opengitops.dev. So with that, when I was a kid, I had a little bit of a side business fixing computers, setting up networking, doing these kinds of things. And one of these jobs actually paid me in a laptop. And so for the first time as a teenager, I couldn't drive yet. I had a laptop. I had mobile computing. It blew my mind. Battery would last about 40 minutes. And so what I would do is I would go out on my skateboard and allegedly, I'm not saying I did this. I'm saying allegedly, I would go out of my skateboard. I'd put in my headphones with my laptop and I would have it ping and tell me when there were Wi-Fi networks. And allegedly, I would use my laptop to see if there was a way that I could bypass these. And a lot of people, if you're familiar with this era, there was WEP encryption. And basically what you could do is you could get in the middle of the Wi-Fi router and the clients, and you could trigger the reauthentication, the reissuing of keys, and then you could snoop on that traffic and you could use it to steal the Wi-Fi password. Now, I'm not saying I did this. I'm saying allegedly I skateboarded around and did this. So this is not an admission of guilt that could be used in a court of law. I want to be very clear about that. But what this taught me is that when it comes to security, if you can get into the middle of a process, you can usually own the process. So that's kind of some of the stuff that we're going to be talking about today. We're going to be trying to solve a couple of problems. So the first problem is, do you know where your software comes from? It's 8 o'clock at night. Do you know where your software comes from? And the challenge here is most processes that we have involve us building artifacts, pushing them to registries, and then later referencing those artifacts, pulling those from the registries and having them deployed. Now, if someone were able to get in the middle and put something and replace your artifact, you might not know about it. You might deploy something that has a vulnerability into it. At the same time, if you baked the image originally and signed it with vulnerabilities, you also have problems. So that's problem number one. There's actually a way that we can make sure that these things haven't been intercepted. And there's also ways that we can make sure that maybe a programmer who has access, maybe their machine is compromised. We can make sure that they can't necessarily push artifacts that are going to be valid and deployed into our servers. And this is also a use case that I've seen in the real world. In the wild, I've seen a company that had a software engineer had their machine compromised. They clicked on a phishing email, it installed a little bit of a rootkit, and then suddenly they started injecting, they basically just started injecting a bunch of malicious code into every code base that they had access to. The engineer had no idea. So you can actually catch stuff like this with this security approach that we're going to talk about. The second problem that we're going to try to solve is how we enforce rules on our cluster. So a lot of people approach this with training. They try to enforce automation and they try to have audits. I have really interesting conversations with people sometimes where they'll say things like, oh, we never touch things in production by hand. That would be out of process. People know not to do that. So we know it doesn't happen. And I love this level of trust that we have for each other. I mean, it just must be a wonderful organization, so utopian that you don't have anybody bypassing the rules. I actually saw a company who had a similar approach years ago. They actually, unfortunately, they had to go through some layoffs, and the team that was maintaining a core piece of software had been laid off. And suddenly, a month later, that service went down. So when people went to go debugging and figure out what's going on, they found out that none of the code changes had been checked in over the last 8 months. Suddenly the debug challenge went from 10 to 100. So it's really good to have audits in place and have processes in place that literally don't allow for people to bypass the right way to do things. And certainly you might have some sort of break glass procedure that involves multiple people getting involved, but you want to make sure that the default path is for people to do things the correct way. That's what this talk is about, doing things correctly by default. And there's another interesting data point for you. A study was done to figure out how they could get more people to opt in to being organ donors. Donating organs saves a ton of lives. It's super important. And if more people donate organs, more people's lives will be saved. So what they did is they started saying, do you want to opt in? And then when they said, do you want to opt out? The default was to donate your organs. Suddenly everybody was willing to donate their organs because if people had to think about it to opt in, they were more hesitant than if they had to opt out. So doing things by default, it works. And the third thing is kind of related. GitOps is really powerful. And GitOps, if you're not familiar with this is the idea, and there are principles on this that I mentioned, opengitops.dev. You can go through and review these principles. Now, for those of you that are not aware of OpenGitOps or the GitOps standard, or maybe you've heard of GitOps, it basically has 4 principles. Your state needs to be defined in a declarative format. So most people are using Terraform. They're like, hey, I checked that box. I'm feeling great. I'm using YAMLs, manifests, things like that. Feeling great. 2, it needs to be versioned and mutable. This is where we start to see people stumble because maybe they use something like a floating tag in their manifest, so it's no longer versioned, or even though they are checking into Git, they're not following best practices to keep those things versioned and mutable. It needs to be pulled automatically. That means you need a software agent that is consistently checking what the desired state of truth is as defined in Git. And then it needs to be continuously reconciled, which means it needs to be aware of what's happening in production and the actual state, and then constantly comparing that against the desired state. And if you can do those 2 things and have a reconciliation policy, you can do GitOps. And that's fundamentally different than the way that we've delivered software with CI/CD that maybe relies on a webhook. Now, you can still use a webhook as part of this process. You just can't rely on the webhook. So how do we make sure that people are doing this? There's some great training out there that we put out that is a GitOps certification using Argo CD course. And it has 2 levels, GitOps fundamentals and GitOps at scale. I think we have over 13 or 14,000 students this year alone. It's the most popular, fastest growing training certification in the world, bar none. And it is quite excellent if I do say so myself. So go to learning.codefresh.io to check that out. But I wouldn't say that we should rely entirely on it. So the first step, when it comes to security, training is the first step. It is not the last step. Okay. So we're going to go into those other steps that we can take. So approaching security, we want to verify our software supply chain we want to enforce security policy, and we want to do it all with GitOps. So I'm going to show you how to do this using SigStore Cosign. SigStore is a project within the CNCF, and Cosign is an excellent tool they put out, which allows us to sign images to verify their provenance. We actually just implemented this in the Argo project. So all of those images starting with 2.4, 2.5 in Argo CD, those are now signed. So to use this, it's pretty easy. There's a command line utility. So you run cosign, generate key pair. And in this case, I'm specifying that it go into my Kubernetes cluster. So this is going to generate a key that is going to be in my Kubernetes cluster that's available for, and this is the cluster that I use for building things. So I can verify that an image was built using that cluster because the keys are only stored and only created on that cluster. So once I've got that key created, I can then sign an image and upload it to a registry. So I could do that manually on the command line if I have access to the keys. I also created, for everybody's benefit, a tool in the CodeFresh workflow template library. So if you're not familiar with this, let's just go look at it really quick. This is the CodeFresh Argo Hub, or rather it's the CodeFresh Hub for Argo, as you can see. And in here, I created this workflow template. So if you're using Argo workflows to build images and you want to sign them, you can just grab this workflow template off the shelf, throw it into your workflow, and you're good to go. So this is a template that's free and available for you to use at codefresh.io/Argo Hub. So let's go back. And once you've done that, you can put it into your workflow template, and you can see here an example of how that was done. You can see we basically just pass in the cosign keys. These are pulled from a secret. And then in the template, it just references which image needs to be signed and the tag needs to be signed. And then we need to make sure that we have our Docker config mounted, because this is going to allow us to push it to the registry that is there. All right. So once we've done that, we have another tool that we're going to use called OPA. Now, many people are familiar with OPA, but they're not familiar with OPA Gatekeeper. So OPA stands for Open Policy Agent, and it is a very popular general purpose security policy engine. So it gained a lot of popularity off of Istio and its implementation with Envoy Proxy, because you can set policies for how OPA deals with those kinds of things. So for example, you can basically set firewall rules on the service level and things like that. This is a graduated CNCF project. It's very well baked. It has a ton of tooling. It's very excellent. Now, it's a newer implementation of OPA is OPA Gatekeeper. This is a Kubernetes controller that sits on your Kubernetes cluster, and you can give it policy, and it will check using injection webhooks to make sure that those policies are implemented. So you can do things like, say, make sure that this image is signed before it's allowed onto the cluster. So that's going to be a tool that we're going to be using. We can also, there's a ton of policies available at github.com/open policy agent/gatekeeper library. And they include things like protecting specific namespaces, preventing privileged containers, blocking and allowing image repositories, ensuring requests and limits are set, limiting how many replicas there are, blocking wildcards, all kinds of stuff. And you can actually write your own in a language called Rego, which I wasn't that very familiar with. Rego is a little tricky to learn, but because the library is so large, I feel like OPA Gatekeeper is a great resource and a great one to use. So the way that this is going to work is when we make changes, Argo CD, I didn't even introduce you to Argo CD. If you're not familiar with Argo CD is a tool that's part of the Argo project. And Argo CD basically lets you set as a policy, this is an application, this is where I want it deployed to, this is where its manifests are from. So you define the source of truth from Git and the destination in a cluster, and then Argo CD will follow the policy, make sure those are kept in sync. You can say, if something changes in my actual state, I want you to override it with my desired state from Git, and that's called auto-healing, self-healing. And then you can also have it do things like pruning. So when I delete something in Git, I want it to automatically be deleted from my resources. And you can basically set policies around that. So we're going to be using Argo CD as our GitOps engine, our GitOps operator, if you will. And what we're going to do is when we make a change, Argo CD is going to apply those manifests to the Kubernetes cluster. That's going to trigger an admission webhook for OPA Gatekeeper to review policy and apply constraints. So there are two components to OPA Gatekeeper. There are policy templates. These are things like I want to check namespaces for some criteria. And then a constraint is the actual policy itself. It says, check against this policy template, which checks namespaces. And these are the values that I'm looking for. And then once it's reviewed those things, if it passes, then OPA Gatekeeper will pass it on to the scheduler, and Kubernetes will continue deploying it. If it doesn't meet policy, it's going to be rejected. So I mentioned that OPA library exists, which is a huge library of policy templates. And these are implemented each one as a CRD, so as a custom resource definition. And you can see that I actually sync them using Argo CD. So I just have a customization that references the OPA library, and then Argo CD takes that and renders these and deploys them into my cluster for OPA Gatekeeper to use. So let's do some demos here. Let's use OPA Gatekeeper to apply some policies. So let's see if I remember how to do this demo. So I've got a couple of policies that I want to apply. No floating tags, only allow images. Actually, before we do this, we need to deploy it. So I'm looking at my cluster here, and you can see I don't have anything deployed other than I've got Argo CD managing itself. I'm using a tool called Argo CD Autopilot. Argo CD Autopilot provides an opinionated, straightforward way of setting up Argo CD in a self-managing way so that everything is recorded in Git, and it goes into Git first, and it's self-managing, and it's awesome. So let me bootstrap my cluster. And when I do this bootstrap of all my components, by default in my repo, I actually had it as part of the normal bootstrap, but for the demo, I wanted to bootstrap it for you. I don't know, because I wanted to be special, I guess. So what I'm going to do is use Argo CD Autopilot, and I've already passed in a Git token and a Git repo in my environment here, so that what this is basically going to do is it's just going to make Git commits for me. So let's actually look really quick at the repository. So you can see this is my repository where I have everything defined, and I have this folder called apps, which is currently empty. Anything in my application folder is going to be synced to is going to generate applications into Argo CD. And what I've done is I've set up an application. I'm going to be setting up an application called Source that is going to pull in the manifests, the application configs from that repo. So I'll show you what this looks like. It'll be more obvious. So I'm going to do app create and source, and then I'm going to specify the app is at this source folder I just showed you under the app configs directory. So this is where I put all my application configurations, and specifically the ones that I want deployed onto OSS Secure, which is the name of the cluster I'm operating on. And the project is also OSS Secure. So when I do this, this is going to just create a commit for me. And that commit is going to generate this config.dir JSON, which is going to be consumed by an application set into Argo CD. So, shoot, it's happening too fast. So you can see this is now triggering a bootstrap that's happening where there are a bunch of applications that are getting deployed. And this includes my my autopilot. This includes my OPA library. Let's look on this page. Here are my OPA constraints, my OPA library. I've got my cosign provider. I've got Gatekeeper running. All this stuff is deployed and up and running. And then you can see it's also deployed some of the stuff for my application. So I have a demo accept app and I have a demo reject app that are being applied. Okay, so we've got everything applied on our cluster. And now we've got policies that we can actually test against. So let's go back and look at this demo. And what we'll do is we're going to go into, whoa. Oh yeah, it's in here. Okay, so I've got my OPA Gatekeeper. All right, I've got an example deploy.yaml. Let's go into the examples folder here really quick. So I've got an accept Argo CD application, I've got a pod not allowed, and I've got a reject non-Argo CD. So what I'm going to do here is let's make sure that I'm using, make sure I'm using the right cluster. Yep, I'm pointing at my OSS secure repo that has been generously been provided by our partners at AWS. And by provided, I mean they let us pay for it and demo it. So what I'm going to do is in my example repo here, I've got this pod not allowed. So what I'm going to do is I created a couple of namespaces in here, and I made one that I'm going to apply security policies onto. Now I could apply this onto all of them, but I'm going to be doing the secure namespace. So I'm going to try to deploy this pod not allowed.yaml. So I'm going to do k apply -f pod not allowed in the namespace secure, and I'm going to just do a dry run on the client here. And when I do that, you can see it was created. Oh, shoot, was my policy not applied? Well, remember, policy application happens on the cluster. So I can't do a dry run client. I need to do a dry run server. So if I do a dry run server, you'll see that this one actually violates policy. So this says that my gatekeeper denied the request for this to be ingested because this image is using a latest tag. I need to specify a specific version. So I have a policy that's set to reject if anybody tries to deploy something using a latest tag, because that's a floating tag. That would violate my GitOps policies. That would violate my GitOps principles. So I'm not going to allow people to do that. So you can see that's pretty straightforward. It worked very well when we do it server side. It restricts the resource. When we do it client side, it doesn't, because it's not aware of the injection webhook. That means that if I were to actually try to apply this manifest, it would get rejected. It wouldn't allow it to deploy. So let's talk about cosign with CI/CD. Now this is the big demo. So now that you understand how OPA policy gatekeeper is working and it's enforcing policies, what we want to do is go through a process. And this is what the entire process would look like. And we can trigger all of this. So starting with, we've got two repositories over here. We've got a GitOps repo. That's the one I just showed you. And then we have an app repo. The app repo is where we define our application. So if we go back and look at this, this repository, this repository just contains what is needed to run everything on my cluster. So all of my, if I just ran a tree on this really quick, let's just do that. Let's go over to here. So you can see, there's actually quite a bit in here. So maybe this isn't the best way to display this. But the way that it is organized follows the principles that are put out on repo organization. CodeFresh has a great blog post on this. And basically, we get all of the automatic generated apps are in apps. And then we have our source repo that has two different sets, app configs and manifests. All of our manifests are in there. Anyway, so then we have our application repo, which is where these things are actually being generated. I'm using this color-coded app. And basically, whenever I cut a release, I want to trigger the creation of my resources and sign them. So if we look at this process, we trigger CI/CD. This is going to run a build in CodeFresh using Argo workflows in the CodeFresh platform. And it's going to sign the image using cosign, using that workflow template I already showed you. And then it's going to push it to the image registry. Once it's in the image registry, it's available to be deployed to. The next step is I add the release to my GitOps repo. Now, this could be done automatically. Here, I've actually done it manually. But there's a great tool called Image Updater that would write this to Git for me. Once I update the release in my GitOps repo, this will sync it using Argo CD. And first, it creates the applications in Kubernetes. The admission controller runs. It will accept or deny resources. And then it will deploy those resources and report the sync status back, right? If it's allowed. So what does that look like? Let's do it live really quick. So I've got in here my my app repository, and I just cut the last release I cut was this version 1.01 secure, and this kicked off a CI pipeline. I can show you what that looks like really quick. Just prove to you that we're doing it. Let's just go into it really quick. I'm not going to trigger a new release because I actually haven't made any code changes since the last time I ran this. Sorry. Let me switch over to here. Okay, and I'm going to go into my delivery pipelines, and I'll pull up my release here. So you can see this is the last release I ran, was this 101 secure. Let's just look at this workflow really quick so you can see what it did. The release was triggered by, once I cut the release, this triggered the build. It built my Docker image. It signed the image using cosign. There's nothing to display here because everything ran properly. And then it ran some report information, did some image enrichment, which is just native into CodeFresh. And of course, all that was pushed into GitHub. All right, so the first part of the demo for that is complete. The next part was to trigger the release. So let's actually look at that really quick. So to trigger the release, if I go over to my GitOps repo and I look at my manifests for my demo accept app, and I look at what's supposed to be deployed for OSS secure, you can see I've got this customization here, and this is specifying what image should be deployed. Now I've actually already updated it to colors version 1.0.1/secure. Now, if I were to change this to an insecure release like blue, purple, or yellow, this would be rejected. So if we go back and look in here really quick, you can see that we have a demo app that's been rejected. Let's find out why this was rejected really quick. And if we look at the events in here, we'll see that this one was failed because we tried to deploy an image that was from a repository that is not in the accepted list. So we verified that it's coming from the right repository, and this one wasn't allowed. In my demo accept application, you can see that it's currently running, looks like it's doing a canary, it has done a canary release and completed. Let's go ahead and trigger a new one, and let's send, you can already see that it's deploying properly when we do a secure image. Let's do an unsecure image. So we'll just change this to blue, go blue. It's not secure, lol. And we're just going to commit that directly for the sake of demo speed. So this will, there's actually no webhook set up from the Git repo here. You could, but it doesn't rely on one. So within, 30 seconds or so, it'll pick up and see that a change has happened, and it will trigger the deployment to go. So this approach is pretty awesome because it lets you do things like make sure that people can't deploy images that weren't built where you expected them to be built. So here you can see this has triggered the resource group. Now, because I'm using Argo 2.5, this does server-side apply. So that means when it tried to create this resource group, we got the event right away. Hey, this is not allowed. In this case, this was blocked because it was checking for the image verification and there was no signature on this. So this was blocked and was picked up. Now, because I'm doing a canary release, all of my service, there's been no service disruption here. And in this case, this one was rejected via the server-side apply. Now, prior to Argo CD 2.5, we actually did client apply. So that means that it would have applied it, but then it would have failed in the cluster. Now, it would still work. You would actually just see a little bit more spinning on this resource because it would be failing creation. So now this is going to be stuck in a progressing state because this is never going to progress. So this doesn't trigger a synchronization fail, whereas it would prior to Argo CD 2.5. So let's go ahead and switch that back to a secure release. And let's do this secure tag that I've already set up here. Go back to being secure. Let's commit that. We'll go back to Argo CD. And now I'm just going to hit refresh on it to trigger the refresh immediately. And you can see now this has been applied. This new resource looks like it's been applied. Oh, wait, is this? Oh, this is just the past one. Oh, so it's still going to create it. Let's just trigger synchronization really quick. Oh, well, actually, it's already deployed. It's this one. Sorry. So that's not a great demo. So let's do, since we already deployed it, let's switch to the other secure image that I have, because it's not going to trigger the canary release. Switch to diff secure release, because I already had it deployed before. So it was just sitting in the canary release. So it was like, yeah, everything looks great now, because because you already had it deployed. So you're just saying that you want to go back to the one that we already have deployed. Everything's fine. So now when we sync it, we'll actually trigger a new resource, a new rollout to trigger with a new replica set. And you can see these pods rolled out just fine. And this is going to go through its canary release. So this will be tested and it will move forward as it's ready. Okay, so we just demoed that. So using OPA with Argo CD, couple of things to mention here. So I tend to think of in Kubernetes, there's kind of two kinds of resources. These aren't official, but I call some fragile. These are resources that once they're started broken, they will always stay broken. And a good example is if you deploy an ingress before an ingress provider, it will get the wrong information on it and it will never be fixed. And then I think there are resilient resources. These are, if failures occur, they will eventually correct. So a great example of this is if you try to apply a resource with a custom resource, but that custom resource definition has not been applied, it will fail. But as soon as the CRD is added, that custom resource will deploy just fine. And that will just take place automatically based on Kubernetes retries. It might take a long time. Maybe you should have better policy around it, but it'll work. So there are tools within Argo CD. One is called sync waves, and this allows you to set the order in which resources are applied. And the other is retry. Retry basically lets us set a policy for when and how often Argo CD should retry applying a resource. So within our group, because we're relying on admission controllers, admission webhooks through Open Policy Agent, that means every resource is potentially fragile when it comes to applying security policy. Let me explain that differently. If I'm trying to apply a security policy to a new resource, I have to make sure that that security policy exists on the cluster before I try to deploy the new resource, right? So this is most important when you're doing a bootstrap, and I'll show you how I did it on here. If you're using, just one other thing. Use retry on policies, because the policies themselves are resilient. They only require that the templates exist for the policies. So we talked about those two things that were on the cluster. And we also want to make sure that the policies are applied before any other applications. So to do this, we're going to need to monitor app sync status. And this does work with multiple providers. So if you're using OPA Gatekeeper or Kyverno or something else, that will work as well. And you can run audits, and 2.5 Argo CD works best. But before 2.5 will work okay. You'll just get different kinds of errors when policies are enforced. So to do sync waves, I recommend following this blog written by Christian. You can follow him on Twitter at Christian814. But this blog, Argo CD Application Dependencies, allows us to set the order in which applications are synced. So what I've done is, and we bootstrapped this earlier, I have a app of apps pattern in Argo CD. Basically, this is an application that references two additional applications, and one I called system requirements and one I called user space. Everything in system requirements has to be deployed before anything in the user space, because system requirements includes all of my policies. To enable this is pretty easy. Starting in Argo 1.8, Argo CD 1.8, we removed this functionality and made it optional. But basically what we can do is we can say that when we're deploying an app of apps, by default, if this one failed, it would still try to apply this one. So we want to prevent that. So what we can do is basically we enable health checks on Argo CD applications, and we basically say this is a blocking operation. If system requirements isn't applied fully, I don't want user space applied. So you can enable that with this config map, which is explained in the blog post I mentioned a second ago. If you're using it with Argo CD Autopilot, here's an example of what that code would look like. to inject that into your manifest. And you can also find this in the OSS secure repo that I was showing you earlier. And then we can use sync waves for these apps. So sync waves specify the order. So under my system requirements application, I have sync wave 1. And under my user space, I have sync wave 2. That means everything has to be applied in my system requirements group of applications, which includes my policies and all that stuff before my user space stuff can be applied, which is my demo applications. So I showed you what that looks like. Yeah, we just did this. So we don't need to do that again. Let's move on to the next thing. So another thing you can do is you can prevent resources from being created that were not created using Argo CD. So this is a policy that I created inside of Gatekeeper, and the policy template exists out there. It's referenced in here. And then all I do is basically I say, check for these annotations. And the annotation I'm looking for is the tracking ID that is set by Argo CD. Now you need to enable this level of resource tracking using Argo CD. Here I set it on service and pod. This is actually incorrect. It should be on deployment and replica set and things like that, because the pod doesn't actually set a tracking ID. But by doing this, I can make sure that nobody deploys an application outside of Argo CD. So since I already demoed what it looks like when you apply a resource and it doesn't work, that's pretty, you probably don't need to see it again, but there you go. Bonus tip, Kyverno. We haven't talked that much about Kyverno. Kyverno is a competitor to OPA Gatekeeper, and it has some additional things that now for this demo, I actually used OPA Gatekeeper and Kyverno. I actually have Kyverno checking my image signing, but then I have Gatekeeper checking my other policies. You can use both. You could use just one. I just found that I wanted to do a demo that included both, so I included both of them, and they work fine together. Now, Kyverno does work a little bit differently because Kyverno actually mutates resources when it applies policy. And this means that if you don't do something, Argo CD will get in a fight with Kyverno. Argo CD says, apply these manifests. Kyverno says, looks great. I've added this information. Argo CD says, where did that information come from? That's not defined in Git. Overwrite that information and remove it. Kyverno says, hey, something just changed, so I need to add my policy information up here. Argo CD says, where did that information come from? And so on and so forth. So we can actually fix this by doing a couple of things. Basically, we can add an ignore differences section that and set a cluster policy that ignores all of the components that are auto-generated by Kyverno. So those will not trigger resynchronization. So you can do that here. The instructions are in the blog post that are linked at the bottom of the slide. And the slides, of course, are going to be provided at the end. So what did we accomplish? Well, we verified our software supply chain, right? We made sure the images were built in the place that they were built. We made sure that was enforced using our open policy agent and Kyverno and Argo CD. We implemented it all with Argo CD to give us a much better enforced security policy. People can't get around these things now. It's just default. It's going to work this way, and it's going to reject you. It's going to reject your release if you try to do something outside of process. If you try to deploy something not using Argo CD, you try to deploy something manually, we can actually reject that. And we could reject any kind of resource that people were trying to deploy that way. And we did it with 100% GitOps. Everything was in Git. And so you can follow along. If you want to go and implement this yourself, you can take my repository that we just looked at, this OSS Secure repository. You can bootstrap this onto your own cluster. Just name it OSS Secure. And you can bootstrap everything that I did right here, and it will all work exactly the same. Tons of resources that I use for this. So use the project repo, Argo CD OPA I mentioned. You can check out all the rest of these great resources after the talk. And of course, as always, go get certified. This slide says over 10K students. It's out of date. It's over like 14,000 this year alone. Argo CD, codefresh.io/argo/get-certified or learning.codefresh.io get you to the same place. And we have GitOps fundamentals and Argo CD at scale are both available. With that, I would take questions, but I think we're out of time. So hit me up on Twitter @todaywasawesome. I would love to hear from you. Also, go check out CodeFresh. We have an amazing software delivery platform that takes advantage of all this stuff and makes it easier, especially to do at scale, especially to do within a large organization. And with that, I'm going to sign off. Thank you so much for coming.